For the next few minutes, we're going to review component isolation and why it can help you solve difficult troubleshooting puzzles. Here is the challenge. It won't boot, you can't speak with the customer, but you know the customer wants it fixed right now. To solve this dilemma, you can dig into documentation and hope to find the exact answer you need. Another approach is to trace power and signal flow in the system. This is the component isolation process he studied when he became certified. If you can solve a troubleshooting problem using quick fixes, there's no point in trying more involved procedures. Likewise, if you are seeing symptoms identical to other systems you have worked on, it makes good sense to look for the same cause. Component isolation makes sense for the most difficult troubleshooting problems, the ones that can eat up your time and still not be solved. Let's quickly review some basic principles of component isolation. Many intermittent issues can be traced to bad connections rather than bad components. If you think that RAM is faulty, remove and reseat it before deciding to change it. If you suspect a logic board, remember that it connects to many other components. In this case, the logic board on a MacBook Pro 15-inch late 2008 has 9 different connectors that should be examined and reseated before writing off the logic board itself. The second principle is to use all your senses as you reseat components. Visually inspect the system for any damage. Are any pins bent? Is there any other sign of damage? Are there any signs of spills? Can you smell any unusual smells? Looking for clues with all your senses makes good sense. The third principle of component isolation is to create a minimal system. The components of a minimal system will vary from model to model. Here we see the components required for a MacBook Pro 15-inch late 2008 minimal system. You need a power adapter, a DC board, logic board, RAM, and an internal speaker. If all of these components are working correctly, when you start the system, you will hear a boot chime. This shows that the power on self-test or post has been passed. The last principle is to build on the minimal system. Add the hard drive and boot the system. Add the optical drive and boot the system again. Repeat with AirPort or Bluetooth. Build the system back up until you find the component that is creating the issue you were trying to solve. If you follow the simple process for troubleshooting everything from no power to optical drive issues, you will be amazed at how many problems you can resolve by checking connections and inspecting hardware before needing to order a single service part. In future podcasts, we will examine specific Macintosh models and how component isolation is used in each of them. As always, if you have a question about this podcast or any of our other podcasts, please email us at svc.trng@apple.com. Thanks for watching.